Hey guys, welcome to a new video. In today's video we're going to look at a Leetcode problem, and the problem's name is linked list cycle. In this question we are given the head of a linked list and we need to determine if the linked list has a cycle or not. We need to return true if there is a cycle, else we return false. So this is the head of the linked list. It contains nodes and there is a integer variable called position which is equal to 1, denoting where the linked list is having a cycle. So here in this case 320 minus 4, and minus 4 is not pointing to null. It is pointing to the first node. And the main point to notice is that this position variable is not given to us, so we can't use this position variable to solve this problem. So let's take a look at the example and see how this problem can be solved. So let's take a look at the example 1. We are given the head of a linked list, so the head will be pointing here. So this is the linked list given, and we are given a position variable pointing at 1, indicating that the cycle points at 1 index. So 0, 1, 2 and 3. So the last node will be pointing at the first index, denoting a cycle. So this cycle continues like this. So generally if there wasn't any cycle, this linked list head would look like this. So after the fourth index, it will point to null, right, basically, and you can clearly see that there is no cycle. So this should be the main intuition, that you will never meet null if there is a cycle inside a linked list. So that should be the main intuition. So in this example there is a cycle, so the last node is pointing at the first node. So this can be solved using the Floyd cycle detection algorithm, where you declare two pointers, the fast pointer and slow pointer. The slow pointer will be pointing at the head, and also the fast pointer will also be pointing at the head. So the main idea in this algorithm is that the fast pointer will be pointing at 2x speed compared to the slow pointer, and at one point of time both slow pointer and fast pointer meet. If they meet, it means that the linked list has a cycle. If they don't meet, fast pointer will point to null, and as I said, if you meet null, you can declare that there is no cycle. So fast pointer will be pointing at 2x speed and slow pointer will be jumping at 1x speed. Now let's code it up and then see a dry run for the same example. So this is the function given to us, has cycle, and the return type is boolean, which means you have to return either true or false. And we are given the head of a linked list. As I said, let's declare the two pointers slow and fast, both pointing to the head of the linked list. The fast pointer will be moving at 2x speed compared to slow pointer. So we use a while loop until fast or fast.next is equal to null. This while loop will keep running. So inside this, let us point the slow pointer to its next node. So slow is equal to slow.next, and fast pointer will be moving at 2x speed. So fast will be pointing at fast.next.next. And if at any point both these pointers meet, it means that there is a cycle inside this linked list. So we return true. And outside this for loop, it means that fast has either pointed to null or fast.next has pointed to null. So we come out of the while loop and you return false. Now let's try to run the code. The test cases are running. Let's submit the code. There you have it, our solution has been accepted. Now let's take a look at the dry run and see how these two pointers are meeting, because for this example you get true as the answer. So there is a point inside this linked list where slow and fast pointers are meeting. So let's take the same example. So slow pointer is pointing at head, and also the fast pointer. We declared the two nodes, and now fast is not equal to null and fast.next is also not equal to null. So move the slow pointer ahead and move the fast pointer to next.next. Now we are checking if slow is equal to fast. No. So we go back to the while loop again. Fast is not equal to null, fast.next is not equal to null. So increment slow and increment fast to fast.next.next. Fast was here, right? So fast.next is here, so fast will point here. Now we check slow is equal to fast. No. So go back to the while loop again. Fast is not equal to null, fast.next is not equal to null, so increment slow and increment fast. Fast.next is this, fast.next.next is this, so fast will move there. Now it will check if slow is equal to fast. Yes, slow is equal to fast, so you return true as the output, and true is the expected output here. You can try for other examples. So the time complexity of this approach is O of n and space complexity is constant, O of 1. That's it guys, thank you for watching and I'll see you in the next video.
talk. Money hung on floor.